Okay, guys, let's do lesson 411 on how we can describe graphs. So graphs of polynomial functions, and we're going to start off looking at them in factored form. So in previous courses, you learned how to graph many types of functions, and so today we're going to work with our graphing knowledge to graph more complicated polynomials. So a polynomial function of degree n can be written in this form. So if you look at this, okay, it's a constant or some number, right? And x to the n, and that exponent then goes down by 1 all the way until there is no exponent. So to give you a better idea, they give you an example here. So this is like x to the 4th, x to the 3rd, x squared, x to the 1st, and then no x. And you can see there's constants in front. So that's standard form for a polynomial. But those can also be written in what's called factored form, or your factors here. Okay, and those factors help us to find zeros, roots, solutions, all these things. And so in this lesson, we're going to develop techniques for sketching the graphs of polynomial functions. So the first thing here, it kind of lets you brainstorm. So, if you want to do that, go ahead. But just for teaching purposes, I'm going to move to the next part. But we are going to do this. We're going to record equations. We're going to sketch the graph. We're going to state the degree. We're going to identify intercepts and then talk a little bit about end behavior here. So let's just look at this first graph here. So sketch the polynomial functions without a calculator. So if you look here at this first function, you have x plus 7 and x minus 9. So if we're looking at degree, because this is in factored form and we're multiplying, we're talking about 1x and 1x. But if you multiply that, that's x squared. So if we're looking at A, so this first graph here, we have a squared graph, or second degree, right? That's our degree. We have 2x intercepts. So again, if you don't know how to solve those, hopefully you learned that in the previous course, but you set each factor there equal to 0 and solve. So x plus 7 equals 0, x minus 9 equals 0. But just for time here, we're going to say x equals negative 7 and x equals 9. Those are our two x intercepts, okay? So then if we were just graphing this, and again, guys, these are just rough sketches. We'll dive into this as the chapter rolls on, but we have an intercept at 9 and we have an intercept at negative 7, right? So our x-intercepts are there. Okay, it's second degree. We should know that's a quadratic, a parabola, a U-shaped graph. We also know it's positive, so it opens upward. So we know that our graph is our end behavior is up. So our even functions are the same in behavior. Our odd functions have different in behavior. So that would give us a general idea of that graph. Okay, and so then if you look at B, okay, so we now have 3, right? We have 3, so we have a third degree. Right, we have 3 x-intercepts. We have one at negative 6. We have one at negative 3. And we have one at 5. Right, so again, if we're graphing this, we have negative 6. We have negative 3. And we have 5. Okay, now a third degree, or a cubic, right, odd function, you have different end behaviors. And so your end behavior is down and then up towards infinity. Okay, so this graph is going to look something like this. Okay, and again, we don't know, we're not 100% sure on how high or low these maximum and minimums get. We'll talk about that in the next lesson, of a little bit of just understanding that once we have this idea of the general shape. So what we've established so far is our squared, or a second degree, right, is up in behavior, right? And then odd, or a third degree, is down up in behavior, right? So what this is telling us, again, even functions go the same, odd functions go differently, right? But what happens as we see negatives in front is those actually flip vertically. So if we had a negative squared function, it would be down. If we had a negative cubic function, it would be up, down. And we'll get into that here in a second, right? So let's look at C. So as we're moving here and we look at C, sorry guys, I don't know why it's doing that. Okay, so we now have x plus 7 squared, so that's 2 x's, and then x minus 5. So this is still a third degree. Okay, but we have something going on here. So our zeros, or our roots, are at -7 and 5. Okay, but what's happening here is this x plus 7 is squared. So this 7 is what we call a double root. Okay? And a double root is a little different, and it acts as x squared would. So if we were just graphing x squared, y equals x squared, it's 1, 0 at 0. It just touches or bounces off, right? And that's the word the book uses, I believe, is it bounces off. So instead of crossing the x-axis, it just bounces off of it. So at -7, we're going to have that double root where it bounces off. Okay, and then at 5, we're going to have one that actually crosses. So again, if we look at a third degree, it's positive. So again, we're down, up. Okay, again, it's going to bounce off here, right? So we're talking about it bouncing off, right? And then we'll curve back upward there. So that's what happens at a double root. Okay, so let's look at D. So notice on D, we have 2, 4, 5. So D is a 5th degree. So still odd, so still different in behavior, right? Notice it's negative now, right? Sorry, it's negative. Okay, so we're talking about it. That changes our in behavior to up, down, right? It's odd, so it's opposite, but it's up, down. We have zeros at 4, -8, and 2. But again, 4 and 8 are double roots. Right, those are double roots. So again, it's going to bounce off at those. So we have -8, we have 2, we have 4. Right, again, so it's up over here. It's going to bounce off. It's going to cross at 2. It's going to bounce off at 4. Okay, double roots. Double roots. The other cool thing about fundamental theorem of algebra, it's just your degree tells you how many solutions there are. Now, they could be imaginary solutions, and we'll talk about that later. But also, if you look at this degree and you subtract it by 1, so 4, you have 4 curves. 1, 2, 3, 4 curves. Right? So you have 5 possible solutions, 4 curves. And so that works all the way back, right? Third degree, 2 curves. Third degree, 2 curves. Second degree, 1 curve, right? And so that's another cool part about that, right? So let's look at E. So if you look at E here, we have 3 4th degree. So that's the same in behavior. It's positive, so it's up, up. So we have up, up in behavior, right? Our zeros are at -4 and 1, right? But coach, it's cubed here. So that's what we call a triple root, right? This is a triple root, right? So it acts as x cubed would. So if you think about x cubed, right, as it gets close, it kind of touches for a while and then comes up, right? So what happens is that 0, it kind of flattens out as it gets really close there to that 0. So the same thing is going to happen at this -4. So when we graph this triple root, we have -4 and 1, right? It's up, up. So we're going to have this flattening out here. It's still going to come down, and then we're going to go up at 1. Okay, so you can kind of see there that that's what a triple root will look like. And so now we know with a double root or a triple root what happens, right? So odds 1, 3, 5, 7 are all going to cross the x-axis. Odd roots. Okay, the bigger the exponent, the flatter it's going to get though. Okay, so like x to the, if we had a 99th root, right, it's going to be really, really flat at that point. Okay, and then even roots, 2, 4, 6, are just going to bounce off. Okay, so they're going to bounce off. They're just going to be really, really flat. And so what I'm going to try to do here, let me see if I can pull up some Desmos, and we can graph this, and I can show you guys what I mean here. So if we look at x and we raise it to the 7th, right, you can see it gets really flat. But if we make that even more so, let's say 27, right, you can see how it gets flatter and flatter. 29, right, or let's say 22, right? So again, any even root's going to bounce off. Any odd root's going to go through. Just the bigger that number is, the more flat, like the flatter it's going to be at that point. Okay, so let's now, I'm going to skip the rest of these, and I'm going to try to make some sense of this. So look back at what you did with polynomial function investigation. Recall roots of the polynomial function are the values such that f of x equals 0. On a graph, the real roots are the x-intercepts. So notice they talk about real roots, okay? And it's bolded there. Because a real root means that we can actually see it, right? An imaginary root, so I try to draw one of these here. So sometimes, and we should know this with parabolas, right? If I had a parabola like this is terrible drawing, guys. If I had a parabola like this, right, there's still considered two possible roots there, but they're not seen on the graph, so they're imaginary roots. Okay, so again, fundamental theorem of algebra, the degree tells you how many solutions there are. Could be real, could be imaginary, but we're talking about the real here. So A, what is the maximum number of real roots a polynomial of degree 3 can have? So we've already seen some third degree, right? Well, it can have 3. There you go, right here. You see there's 1, 2, 3 real roots. Okay. What do you think the maximum number of real roots a polynomial of degree n can have? Well, n, right? Again, that degree tells you how many possibilities there are. There's n possibilities. Okay. So can a polynomial of degree n have fewer than n real roots? Okay, so look here. So here's a third degree, right? But there was only 2 roots here. 1, 2. So can it have less? Yes, it can, right? So it can go from the degree or less. Okay, a squared factor produces a double root. Okay, so we talked about this. So for example, p to the x, that 5 plus x squared is a double root. What effect does it have? It just bounces off, right? So we talked about that here, right? That -7, it just bounces off. We also talked about a cubic factor root. So if you look at e, x plus 4 cubed has a cubic factor root. And so that just goes through the x-axis there.